Hello guys, welcome to Wednesday's topic. So far we've also learned about stratosphere and mesosphere. We know that mesosphere is the middle layer of the atmosphere, also the coldest, but we've learned that stratosphere is more layered, as in the gases in the stratosphere are more layered and do not really mix with each other very well. But today we're going to learn about the fourth layer, which is the thermosphere. If you look to the right of the presentation, you can see the picture. And the layer which has the space shuttle, the auroras, and the International Space Station is the thermosphere. Clearly, it is the uppermost layer of the thermosphere, of the atmosphere. Anything above that becomes exosphere or outer space. But this is the uppermost layer, and here temperature increases as you go higher up. So with increase in the altitude, the temperature increases, and that is because of something called energy absorption. So atoms which are here, atoms of nitrogen and oxygen, they kind of absorb the high energy from solar radiation. So when they absorb the solar radiation and they release thermal energy, which is heat energy, it causes the temperature in that area to be higher than 1000 degrees Celsius. Now, when you think of an area that or a place that's really hot, with high temperature, you normally think it's really hot, right? But not thermosphere. So even though the temperatures here are like 1000 degrees Celsius, which is crazy, it is actually not hot. It does not feel hot in the thermosphere. And this is because temperature is actually very different from heat. So temperature is actually the measure of the average energy of particles in motion, right? And the high temperature in the thermosphere means that the particles in this layer, the gas particles, the atomic particles in this layer are moving very fast. That's why they have a high temperature. On the other hand, heat is kind of like the transfer of thermal energy, the heat energy between objects of different temperature. Right? So if I have cold hands and a friend of mine has warm hands and we hold hands, we are transferring energy. We are transferring thermal energy when we touch each other. So the warm temperature or warm heat from my friend's hand is transferring to mine, right? So when you touch a particle, when particles touch, they kind of displace and they exchange energies. And heat is the transfer of thermal energy. And the trick is that particles must touch one another to transfer thermal energy. If they're not touching, there's a good chance that the thermal energy will not transfer. And the space between the particles in the thermosphere is actually so great, it's so wide, that the particles do not actually get the chance to transfer much energy. And the density of the molecules here, or air particles here, is so low that particles don't get to collide as often. And if they don't collide, they're not going to touch. And if they don't touch, they're not going to transfer energy. So even though the particles are at a very fast pace, even though they're revolving or moving or in motion very fast, there are so less particles here that they just don't collide with each other, or they just don't touch each other, because of which it does not really get very hot. Now let's look at ionosphere. Now, ionosphere is also known as the home of the auroras. If you look here, you will see aurora. So in the upper mesosphere and the lower thermosphere, so like around this area, in the upper mesosphere and lower thermosphere, nitrogen and oxygen atoms absorb harmful solar energy. And as a result, what happens is that the thermosphere's temperature rises and gas particles become electrically charged. And when they become electrically charged, they can be known as ions. And because they're known as ions, this part of the thermosphere is actually called ionosphere. And in polar regions, these ions radiate energy as shimmering lights, and these lights can be seen again in the North or the South Pole and are called as auroras. They can also reflect AM radio waves. So AM radio waves are commercial radio waves, and when conditions are right, it can travel all around the world by reflecting off of the ionosphere. And these radio signals kind of like they just bounce off the ionosphere and are sent back to Earth. This is how commercial radio waves actually work. And this is most of the information that I have for you guys today. And I hope you guys have a great day, and I hope you guys have no problem understanding the content. If you do, please contact me, and I will see you later. Bye.